Hey everyone! So we're always hearing about how brilliant and powerful AI models are getting, right? But there's this other side of the story that's just as important, maybe even more so, and it doesn't always get the spotlight: performance. Today, we're going to get into how we take these incredible massive AI brains and actually make them fast, efficient, and, usable for all of us in the real world.
And this quote, this just nails it. See, performance isn't just some nerdy technical thing for engineers to worry about. No way! It's about whether that cool new AI app on your phone is actually a success or a total flop. It's about making AI work for people, not just in a lab.
All right, so here's our game plan. First, we'll look at the big challenge we're up against. Then we'll dive into the three main ways to fix it: making the AI's brain better, giving it the right hardware muscles, and using smarter software. And we'll wrap up by talking about why this is a job that's never really done.
Okay, let's jump right in. So, at the very core of modern AI, there's this real tension. It's a classic trade-off, really. We're building these AI models that can do things we only dreamed of a few years ago. But all that power, well, it comes at a pretty hefty cost.
And here's that trade-off in black and white. On one side, you've got these absolute titans, AI models with billions, literally billions of parameters that can write poetry or create stunning art. It's amazing stuff. But then there's the reality check. To run these things, you need a ton of computing power. They guzzle electricity, and honestly, they can be painfully slow. And this isn't just some abstract technical issue. I mean, this stuff has real-world consequences. Think about it. A recommendation on a shopping site that takes forever to load, you've already moved on. A chatbot that lags, you're going to close that window and find another company. And when we're talking about something like a self-driving car, a delay of just a few milliseconds isn't an inconvenience. It's a critical safety risk.
All right, so how do we start to fix this? Well, the first place to look is at the source of the problem, the AI model itself. How can we make the AI's brain not just super smart, but also, lean and efficient?
So the first technique is a really clever one. It's called knowledge distillation. Just picture a brilliant, experienced professor. That's our huge teacher model. Now, instead of trying to cram that professor's entire brain into your phone, you have a smaller student model. Just watch the professor and learn from their answers. The student ends up almost as smart, but in a much, much smaller package. And the process is pretty elegant, actually. You start with your giant teacher model. Then you get a smaller student model to basically mimic the teacher's outputs. The result? You end up with this nimble, efficient little model that's perfect for running on, say, your smartphone, and you barely lose any of that original brain power.
Okay, next up, we've got something called pruning, and it's exactly what it sounds like. Think of a gardener carefully trimming a bonsai tree, right? They snip away all the extra branches to reveal the beautiful shape underneath. That's what pruning does to a neural network. It finds all the unnecessary connections, the digital dead weight, and just snips them away. And the results? They are absolutely wild. I mean, look at that number. You can shrink a model by 80, even 90%. We're talking about the difference between an app that hogs all your phone's memory and crashes all the time, and one that just works seamlessly. And the craziest part? You keep almost all of the accuracy.
And the last trick for the model itself is called quantization. Here's a simple way to think about it. Instead of using a super precise number like 3.14159, you just round it to something simpler like 3.14. That's basically what an AI model does during quantization. It uses less precise numbers for its math, which makes the whole thing smaller, way faster, and a lot less hungry for memory and power. But of course, a super efficient brain is only half the battle. It needs the right muscles to actually do the work. You wouldn't put cheap gas in a Formula One race car, right? Same idea here. To get peak performance from AI, you absolutely need specialized hardware. So let's break down the hardware lineup. Think of the CPU, the processor in most computers, as a jack of all trades. It can do a little bit of everything. But a GPU, that's a specialist. It's a parallel processing beast built to do thousands of things at the same time, which is perfect for AI. Then you get into the super specialized stuff, like Google's TPUs, which are designed from day one for one thing and one thing only: running neural networks. And for really custom jobs, you've got FPGAs, which are like programmable chips you can tailor for one specific task to get insane efficiency.
Okay, now we need to talk about the real unsung hero in all of this: the software stack. You can have the smartest AI model in the world and the most powerful hardware on the planet, but if the software that connects them isn't up to snuff, you're just wasting potential. You're leaving so much speed on the table. And this software stack is a whole world of its own. You've got the big frameworks like TensorFlow and PyTorch that everything is built on. Then you have these incredibly smart compilers that work like master translators. They take the AI code and rewrite it into the perfect dialect for whatever hardware you're using. Even simple-sounding things, like how you bundle up data before you process it, that's called batching, can make a huge difference in speed. It's all about squeezing every last drop of performance out of the system.
And all of this brings us to a really critical point. Optimization isn't a one-and-done kind of deal. You don't just tune up an AI system, check a box, and walk away. It's not a project with a finish line. It's a constant, ongoing mission.
Yeah, this is really the main takeaway here. It's a cycle. You have to be constantly monitoring how your AI is performing out in the wild, looking for slowdowns, finding those new bottlenecks, and then going back to tweak your strategy. Because the data is always changing, the models are always getting updated, and so the optimization work has to keep up, step for step.
And when we look to the future, man, it gets really exciting. We are on the verge of some completely new paradigms in computing. We're talking about things like neuromorphic computing, chips that are literally built to work like a human brain. We've got quantum computing on the horizon, promising speedups that are hard to even imagine. And maybe the wildest idea of all, AIs that learn how to optimize other AIs. It's pretty mind-bending stuff.
So I'll just leave you with this question to chew on. We spend so much time talking about the race to build bigger and bigger AI models, but what if the real breakthroughs, the ones that truly change everything, don't come from making models bigger, but from making them faster? What if the future of AI isn't just about being smarter, but about being so fast and efficient that it's accessible to every single person everywhere? Just something to think about. Thanks for tuning in.